Training a model can take hours, days, or even weeks, so it is important to have a mechanism to store those trained models in our storage so that we can use them later on. Today we are going to talk about how to store objects or a trained model in Python. There are several options for storing a trained model or objects in Python. A very common one is pickle. Pickle is commonly used if you have many objects like dictionary of strings. It is written in C, so it can quickly handle storing and restoring. Another option is joblib. Joblib is similar to pickle, but it has a special mechanism to handle array buffers. So if you have a long numpy array, joblib is much faster than pickle, and joblib is written in pure Python. The problem with pickle and joblib is that they are not language independent. That means if you store any object or model using pickle or joblib, you cannot restore the model using other language like Java or MATLAB or R. Another problem is if you write an object or store an object or model using pickle or joblib in a specific Python version, it may not be possible to open that object or model in a next version of Python. Other than that, pickle and joblib is very simple to use. In many cases, they are very fast. To make storing and restoring language independent, common techniques are using JSON format, YAML format, and HDF5 format. JSON is standardized and language independent. JSON is also more secure and faster than Pickle. YAML is similar to JSON, but it is not standardized. YAML is commonly used for configuration, while JSON is used for data serialization or transferring data over internet or transferring data through APIs. HDF5 format is hierarchical data formats. It supports more complex, large, and heterogeneous data types. It is in a way similar to file directory. Usually, while we try to store trained weights in a model, we use HDF5 format. We will see some examples, especially we'll see how to use pickle to store a tokenizer object, and we will see how to use JSON and HDF5 format for storing a trained neural network model. At the beginning, we will see how to store a tokenizer object using Python. So here we have several documents. Each line represents a document. All these documents are assigned to xtrain variable. Then we import tokenizer. We need to say what will be the maximum size of dictionary. Then we create the tokenizer object. Then we feed our tokenizer object using our documents, and for that we use the function called feed on text. After tokenizer is feed on our documents, that is xtrain, we then use the tokenizer to convert each documents into a sequence of numbers. So that is, each word in each document will be replaced with corresponding index in the dictionary that tokenizer has built from the documents we provided. So this will be like this. It is taking a little bit of time. Okay, so we have trained our tokenizer, or we have fit our tokenizer on documents. That is, it has built a dictionary with indexes for words. So we can see that xtrain is, each document has been transferred to corresponding indexes for each word. Now we import pickle to save this tokenizer object. So import pickle. Then we open a file named tokenizer.pickle. We open the file as binary writable, and then we use pickle.dump to write our tokenizer object to this file. So we write the tokenizer using this file, and for writing the file we use pickle.heist protocol as our writing protocol. So it is written on the storage. Then we want to load our tokenizer object using pickle. So for that we use pickle.load, and then we need to say what will be the file that pickle will read. With open tokenizer.pickle rb, that is read binary file. Then pickle.load, we provide the file name. Now we open the stored tokenizer object using pickle.load. Now let us check if we have successfully restored our tokenizer object. So for that, we convert our documents, that is our document assigned to x underscore train. Here the tokenizer object is restored from our storage. We use this tokenizer to convert our documents. Let's see what happens. So yeah, it has successfully converted all the documents into numbers. That is, all the words in each document are converted into corresponding index in the dictionary. So we have seen how to store a tokenizer object using pickle, and again how to restore it using pickle. Now we will see how to store a neural network model using JSON and HDF5. For this example, we will use Pima Indians diabetes dataset. So we will use JSON to store our neural network architecture, and we will use HDF5 to store the trained neural network words. To create our neural network model and train it, so we will use sequential model and dense layer. So we import sequential from keras.models, and we import dense from keras.layers. And to read stored model from JSON, we import model underscore from underscore JSON from keras.models. And to store and restore our trained weights, we will use numpy. So we import numpy. To make our model reproducible, we first fix the random seed. So numpy.random.seed, we assign the seed to 7. So we import all the necessary libraries and then assign our random seed to 7. We use numpy.random.seed method to assign our random seed. So now we read our Pima Indians dataset using numpy.loadText, and we use comma as delimiter. We can see that our dataset has number of features, and then it also has a conclusion or decision based on those features. Each column represents a feature, and the last column in this matrix represent a decision or a conclusion based on those features. So let us separate this matrix. So the x matrix will have all the features, and the y vector all the conclusions or decisions based on those features. Let's do that. Now we need to create our model, so we will use sequential as our model. Then we will add some dense layers. So our first layer will have 12 perceptrons, and the input size will be 8, and in this layer we will use ReLU as our activation. And the second layer will have 8 perceptron, and the activation will be ReLU. And the final layer will have only 1 perceptron, because we will use our model as binary classifier. Because it is a binary classifier, we can decide the class of our instance only using 1 perceptron. And to have a probability distribution over the classes, we will use sigmoid activation in our final layer instead of ReLU. Now after we have created our model, we need to compile it. So when we compile it, we need to say how we want to calculate the loss. So we will use binary cross entropy, and we need to tell it what will be our optimization algorithm. Here we say that Adam optimizer will be used in this specific model, and we also need to tell it what will be the metrics to report the performance of our model. We will use accuracy as performance measure in this model. Now let us compile our model. After we have compiled our model, we need to fit this model using our training data set. We have x as the feature matrix and y as the conclusion or decision vector. We will use 150 epochs, and our batch size will be 10. Verbose is assigned 0 so that we don't get all the execution details. We just want to see our final model after it has been trained. It is taking a little bit of time. Okay, our model is trained. Now let us evaluate the model. Let's see what is the performance. So we have got accuracy 77.73%. In this specific case, we use our training data to evaluate the model, but usually we have a separate test dataset or holdout dataset that we use. Now let us store the model. To store the model, we need to store two things. One is the architecture of the model, and then we need to store the weights that we have trained from our training data set. Now first let us serialize the architecture of the model and then write it in the file. So we are using model.toJSON to get the JSON representation of the architecture, and then we write this JSON to a file called model.json. Then we need to serialize our model weights. So for that we will use model.save weights, and we will save the weights using model.h5 file. Model.h5 file will contain actually HDF5 format. Saved model to the disk. Now let us read the JSON architecture and weights to recreate our model. So first let us read the architecture. So for that we read the file, and then we use model from JSON to recreate model architecture from the file. Now let us read the weights from the file. For that we use load weights. So we have first read the architecture of the model and created the model, and then we have assigned those weights to the model. So our model is ready to be used. Now we compile the model and evaluate the model using our dataset. So we see that the accuracy of the model is 77.73%, exactly same as before we stored the model to our storage. That time the accuracy was 77.73%. So that means we have successfully stored our model, restored it, and successfully evaluated it.